Good morning. Today we are going to start an interesting topic, binomial distribution. We have studied meaning of types of a random variable and probability distribution of a random variable, right? The probability distribution is denoted by P of X. Probability distribution is denoted by P of X, which is referred to as probability mass function, PMF. It is a rule that explains how the total probability 1, total probability is always 1, but how the total probability 1 is distributed among the various values of a random variable X. Now, in this particular topic, binomial distribution, we are going to study a particular probability distribution. So, binomial distribution is a special type of probability distribution. First, we discuss Bernoulli trial. Now it is Bernoulli trial, a random experiment which has only two mutually exclusive outcomes. A random experiment which has only two mutually exclusive outcomes, namely success and not success. Not success means failure, is called dichotomous experiment. I repeat this, a random experiment which has only two mutually exclusive outcomes, namely success and not success, that is failure, is called dichotomous experiment. If a dichotomous experiment is repeated n times, and if in each trial the probability of success that is P, of course 0 less than P less than 1 is constant, then all such trials are called Bernoulli trials. For example, consider a die to be thrown, say 15 times. Let the result be an even number, and if we say that getting an even number is success, otherwise it is failure, then the probability of a die showing an even number is what? Out of 6, 3 are even, 2, 4, 6, so that probability is 1/2. Note that this probability remains the same in each trial, and therefore it is called as Bernoulli trial. Another example, we draw a card without replacement, then the probability of getting a red card is what? 26/52, that is half in the first trial, and again it remains the same in the second trial. But if it is not replaced, then it will be what? It will be 25/51. Is that clear? So this is also a Bernoulli trial. Now, the next part is binomial distribution. Listen to me carefully. An experiment of n repeated independent Bernoulli trials is called a binomial experiment. So what is a binomial experiment? An experiment of n repeated Bernoulli trials is called as binomial experiment. Consider a binomial experiment. Let the outcomes in each trial be a success, which is denoted by capital S, or failure denoted by capital F. Thus, probability of success is usually denoted by P. And what will be the probability of failure? It is nothing but Q, that is 1 minus P. Suppose X is a random variable, and how X is defined? Number of successes. So we are now interested in finding probability of an event that n trials result in exactly X successes. So what will be number of failures? Number of failures will be n minus X. Let one particular sequence of x consecutive successes followed by n minus x failures. So let me explain. Success, success, success. How many times? X times, followed by, see, number of trials is n, right? So if number of successes is x, what will be number of failures? It will be n minus x. Now, probability of success is p. How many successes? X. So what is the probability? P raised to x. How many failures? N minus x. Probability of failure is f. So f means q rather. So it will be q into rather q raised to n minus x. Now next part is important. The number of possible orders. The number of possible orders of x successes and n minus x failures in independent trials is NCX. See, it is not necessary that first x trials should result in success and then remaining n minus x trials in failures. We do not know the exact order, and that is why the answer is not just p raised to x into q raised to n minus x, but you have to multiply it by NCX. And therefore we say that what is p of x equal to x, capital X equal to small x? It is nothing but NCX p raised to x into q raised to n minus x. Okay, this is known as binomial distribution. So if you are asked to define binomial distribution, how will you define it? A discrete random variable x, a discrete random variable x is said to follow a binomial distribution with parameters n and p. Small n means number of trials and p, small p, means probability of success. If its probability mass function PMF is given by what? P of capital X equal to small x, in short P of x, P of small x equal to NCX P raised to x into Q raised to n minus x, for which values of x? X equal to 0, 1, 2, 3 up to what? N, and equal to 0 otherwise. Now what are the restrictions? The restrictions are 0 less than p less than 1. N is what? 1, 2, 3 and so on. And what is probability of failure? It is 1 minus probability of success. Okay, so this is nothing but binomial distribution. Actually, binomial distribution can also be represented in tabular form. Yes, this is tabular form. See, capital X means number of successes, not a single success. Means all n are failures. Probability of failure is q. So first trial is failure. So probability q into q into q. How many times? N times. So q raised to n. And what is NC0? Yes, it is 1. Now, one success means remaining n minus 1 failures. Now, we do not know whether the first trial is resulted into success or failure. And that is why NC1 P into Q raised to n minus 1. 2 successes. So NC2, 2 successes. So P into P. So remaining n minus 2 failures. So Q into Q into Q. How many times? N minus 2 times. Up to what? All n trials result into success. So P product n times. So P raised to n. So NCN, yes, it is 1. So 1 into P raised to n, that is P raised to n. Is that clear? Now, interesting part is if you add all these, you will notice that this is expansion. This is expansion of p plus q raised to n. Now, p plus q is nothing but 1. So 1 raised to n, that is 1. This agrees to the fact that for probability mass function, sum of all probabilities is 1. And of course, individual probabilities. So in this case, I will say p of x has to be greater than or equal to 0. Is that clear? Initially, we use the term Bernoulli trial, right? I'll repeat that part after this explanation part is over. Now, what are the conditions for binomial distribution? The binomial distribution is used whenever each of the following is satisfied. Number 1, trials of experiment are Bernoulli trial. That is, it results into either success or failure, and probability of success remains the same for each trial, right? So the performance of a Bernoulli trial results in an outcome that can be classified either as a success or a failure. Then number of trials, which is usually denoted by small n, is finite. All these trials are independent. The probability of success is constant from trial to trial. That is, trials are repeated under identical conditions. Clearly, p plus q equal to 1. So what is q? It is nothing but 1 minus p. Here we use an important notation. We write capital X tilde, T-I-L-D, B, N, P. How to read this? We have to read this as X follows binomial distribution. This random variable capital X follows binomial distribution with parameters N and P. I repeat this part. Random variable X follows binomial distribution with which parameters? N and P. What does small n stand for? Number of trials, number of times the experiment is repeated. And what does small p stand for? It is probability of success. How to define success? That we have to decide. So P is probability of success. So small q, which is 1 minus P, will be probability of failure. Is that clear? The last part, in this case also, these two terms are defined, mean and variance of this binomial distribution. Now, mean of binomial distribution is defined to be NP. We know that mean is denoted by mu. It is actually expected value. So E of x equal to mu equal to NP, and variance is defined to be NPQ. What is Q? Probability of failure. So clearly mean is greater than variance. And we know that standard deviation is defined as positive square root of variance. Is that clear? So if you know this much about binomial distribution, you can solve all the sums. Now, first one, exercise 8.1. A die is thrown 6 times. If getting an odd number is a success, find probability of 5 successes, at least 5 successes, at the most 5 successes. See, they have defined success as what? Getting an odd number. So, how to write the solution? Let capital X equal to number of successes, that is number of odd numbers, because getting an odd number is success. So small p equal to probability of getting an odd number in a single throw of a die. Now when a die is thrown, possible outcomes are 1, 2, 3, 4, 5, 6. Out of these 6, 3 are odd, 1, 3, 5. So probability of getting an odd is 3 by 6, that is half. So it is probability of not success, that is failure. It is 1 minus half, that is again 1 by 2. Okay. Now experiment is performed how many times? 6 times. So number of Bernoulli's trials, small n, is 6. After that, you have to say, so random variable x follows binomial distribution with which parameters? NP, n equal to 6, p equal to half. Simple. Then you have to say the probability mass function of random variable x is given by p of x equal to x, or just say p of small x equal to what? NCx. Formula can be remembered easily. See, this is similar to what? General term in the expansion of a plus b raised to n. So it is NCx p raised to x into q raised to n minus x. So here p of x equal to what? 6cx into half raised to x into half raised to 6 minus x. Use laws of indices. 6cx into half raised to 6. X goes from 0, 1, 2, 3, 4, 5, 6. Now in the first part, what is asked? Probability of 5 successes. So p of x equal to 5. So p of 5, which is 6c5 into half raised to 6. I hope you know how to find NCR. In fact, here they have used the result that NCR is NC n minus r, complementary combinations. Or you may directly find this 6c5 is 6. What is half raised to 6? 1 upon 64. So 6 upon 64, that is 3 upon 32. So what is the required probability? 3 by 32. Second part, probability of at least 5 successes. So p of x greater than or equal to 5. So either p of 5 or p of 6. Actually, I should say p of 5 plus p of 6. So 6c5 half raised to 6 plus 6c6 half raised to 6. Simplify to get 7 upon 64. Third part, at the most 5 successes. So p of x less than or equal to 5. If you consider original event, then you have to consider p of x equal to 0, 1, 2, 3, 4, 5. So we consider complement. So required probability is 1 minus p of x greater than 5. Means what? P of 6. So 1 minus p of 6, that is 1 minus 1 upon 64, that is 63 upon 64. So this is the required probability. Now second sum, a pair of dice is thrown 4 times. If getting a doublet is considered a success, find the probability of 2 successes. Let x be number of doublets. So p is probability of getting a doublet when a pair of dice is thrown. Actually, when 2 dice are thrown, there are 36 sample points in the sample space. What do you mean by doublet? Means same score on both the dice. So out of 36, these 6 are in favor, and that is why small p is what? It is 1 upon 6. So what is probability of non-success or not success? That is probability of failure. Q 1 minus p, that is 1 minus 1 upon 6, which is nothing but 5 upon 6. Okay. Now, experiment is performed how many times? It is performed 4 times. See, read the sum. A pair of dice is thrown 4 times. So n equal to 4. Therefore, random variable x follows binomial distribution with parameters np. What is n? It is 4. And what is p? 1 upon 6. And after this, you have to say the PMF probability mass function of random variable x is given by, you have to mention this, is given by what? P of x equal to, you can write formula first, NCx p raised to x q raised to n minus x, and then particular values n equal to 4. So 4cx, what is p? 1 upon 6. So 1 upon 6 raised to x into q, 5 upon 6 raised to 4 minus x. Okay. And x can assume which values? X can assume values 0, 1, 2, 3, 4. Why up to 4 only? Because experiment is performed how many times? 4 times. Now it is asked probability of 2 successes. So P of 2 successes, that is P of x equal to 2 is what? P of 2, 4C2, 1 upon 6 square into 5 upon 6 raised to 4 minus 2. That is again square. 4C2 is 6. 1 upon 6 square. 5 square is 25 upon 6 square. 1 6 gets cancelled. So 25 upon 6 cube, that is 216. So answer is 25 upon 216. Third sum. There are 5% defective items in a large bulk of items. What is the probability that a sample of 10 items will include not more than one defective item? Let x be number of defective items. Here we define that getting a defective item is a success. So P, probability of getting a defective item, 5%. Percent means per 100 for every 100. Out of 100, 5 pieces, that is items are defective. So it is small p, 5 upon 100, that is 1 by 20. So it is probability of failure q, 1 minus p, that is 1 minus 1 by 20, that is 19 by 20. See, you have to read the problem again and again. A sample of 10 items. So number of Bernoulli trials small n is 10, and therefore x follows binomial distribution with parameters 10, 1 by 20. So it is the probability mass function of x. It is p of x equal to nc x p raised to x q raised to n minus x. This is the formula. Substitute the values n equal to 10, p 1 by 20, q 19 by 20. Okay. So this is the formula. Now, what is asked? Not more than one defective item. Okay. So required probability is p of x less than or equal to 1. I hope you are getting this. What is asked? Probability that sample of 10 items will include not more than one defective item, means at the most one. If number of defective items is 0, we are more than happy. But even if it is 1, it's okay. But 2 or more defective items not allowed. Means it is p of x equal to 0 plus p of x equal to 1. Okay. So this is the required probability. Now calculation part. 10c 0, 1 upon 20 raised to 0, 19 upon 20 raised to 10 minus 0, that is 10, plus 10c 1, 1 upon 20 raised to 1, 19 upon 20 raised to 10 minus 1, that is 9. So how will you simplify this? This is basically 10c0 is 1, 1 by 20 raised to 0 is 1. So this is basically 19 by 20 raised to 10 plus, what is that? 10c1, 10. So 10 by 20 into again 19 by 20 raised to 9. Okay. I can take 19 by 20 raised to 9 common. Is it? So what remains in bracket is this 19 by 20 plus, that is why I haven't written half, because again in that case we'll have to find LCM. So 10 by 20. So this is 19 upon 20 raised to 9 into 29 upon 20. Keep answer as it is. So required probability is this. Or you may say this is 29 into 19 raised to 9 upon 20 raised to 10. Same thing. Fourth one, 5 cards are drawn successively with replacement from a well-shuffled deck of 52 cards. Find the probability that first, all 5 cards are spades. Second, only 3 are spades. Third, none is a spade. See, it is all about spades. So how will you define X? Number of spade cards. So it is small p, probability of getting spade card. Now out of 52, 13 are spades. So what is the probability of getting a spade card? 13 upon 52, that is 1 by 4. So what is probability of failure? Q, 3 by 4. Now 5 cards are drawn. So number of Bernoulli trial, n equal to 5. So X is a random variable which follows binomial distribution with which parameters? 5 and 1 by 4. So it is probability mass function of random variable X, P of X equal to NCX, P raised to X, Q raised to N minus X. That is 5CX, 1 by 4 raised to X, 3 by 4 raised to 5 minus X. X assumes which values? 0, 1, 2, 3, 4, 5. Now different probabilities are asked. First one, probability of all 5 cards are spade. All 5 are spades. Actually, you can directly say that in the first part, we need P of X equal to 5. For that also you'll get full marks. So it is what? 5C5 1 upon 4 raised to 5 into 3 upon 4 raised to 5 minus 5, that is 0. What is 5C5? It is 1. So it is 1 raised to 5, that is 1, upon what is 4 raised to 5, means 2 raised to 10, 1, 0, 2, 4. Actually, if denominator is power of 2, integral power of 2, that rational number can be expressed as terminating decimal, but you can write final answer as 1 upon 1024. Second part, probability of only 3 cards are spades. So P of X equal to 3. It is 5C3, 1 by 4 cube into 3 by 4 square. So 5C3 is 10, 1 by 64, 9 by 16, 2, 5, 10, 2, 32, 64. So 9 into 5, that is 45 upon 5 and 2. Third part, probability of none of cards is spade. That is P of X equal to 0. 5C0 is 1, 3 raised to 5, 243, 4 raised to 5, 1024. So the answer 243 upon 1024. Fifth one, the probability of a bulb produced by a factory will fuse after 150 days of use is 0.05. Find the probability that out of 5 such bulbs, first part none, second part not more than 1, third part more than 1, fourth part at least 1 will fuse after 150 days of use. Let capital X denote number of fuse bulbs. P is probability of a bulb produced by a factory will fuse after 150 days of use. They say it is 0.05. So what is Q? 1 minus P, so 0.95. N equal to 5. Because they say that find the probability that out of 5 such bulbs, so N equal to 5. Therefore, X is a random variable with binomial distribution having parameters 5, 0.05. So what is the probability mass function of X? It is NCX, P raised to X, Q raised to N minus X. That is 5CX, 0.05 raised to X, 0.95 raised to 5 minus X. X can assume values 0, 1, 2, 3, 4, 5. First part, probability that none of the bulbs will fuse after 150 days of use. So P of X equal to 0. So 5C0, 0.05 raised to 0, which is 1. 0.95 is to 5. So this is the answer. Actually, if only this part is asked for 4 marks, it is better that you find this answer using log tables. But if 3 parts are asked for 4 marks, you can write final answer in this form only. Second part, probability of not more than one bulb will fuse after 150 days. Okay, so P of x less than or equal to 1, or you may say P of x less than 2, same thing. So P of 0 plus P of 1, substitute the values. You have to simplify patiently. Take 0.95 raised to 4 common to get this in bracket. So it is 1.2 into 0.95 raised to 4. If possible, simplify this using log tables. So this is the second part. What about third part? Probability that more than one bulb will fuse after 150 days. So P of x greater than 1. Here it is better if we consider the complement. Probability of complement. So what is required probability? 1 minus P of x less than or equal to 1. This we have already obtained. So what is the required answer? 1 minus 1.2 into 0.95 raised to 4. So that's it for today.